Chapter 3, Section 4, Solving Multi-Step Inequalities. Just like with equations, when we're solving inequalities, we're going to have to combine like terms, use the distributive property. But unlike equations, we're going to have to flip the inequality sign when we multiply or divide both sides by a negative, just like what we talked about a couple days ago. The first example says, what are the solutions of 6 plus 3t are greater than 15? To solve this inequality, the first step we have to do is subtract 6 from both sides to isolate my variable. When I subtract 6, I get 3t is greater than 9. Now to get t by itself, I have to divide by 3 on both sides. And when I do that, I get t is greater than 3. This example does not ask me to graph the solution, so I do not have to plot it on a number line. The next example says, which is the solution of 2 parentheses t minus 1 plus 3t is less than 2. Notice that in this example, we are going to have to use the distributive property. We're going to have to do 2 times t and 2 times negative 1. Notice I do not distribute to the plus 3t because it is outside of the parentheses. When I distribute, I get 2t minus 2 plus 3t is less than 2. Now that I have distributed, I can combine my like terms. Notice that I have a positive 2t and a positive 3t on the same side of my inequality sign. So I can regroup them and do 2t plus 3t, which gives me 5t. The subtracting 2 is still there, and then it's less than 2. Now it's a two-step inequality. I have to add 2 to both sides, and I get 5t is less than 4. And when I divide by 5, I find that t is less than 4/5. Now the original question says, which is the solution of the inequality 2 parentheses t minus 1 plus 3t is less than 2. If you look, it gives me options. A is 0, B is 1, C is 2, and D is 3. Well, when we solved for t, we found that t is less than 4/5. 4/5 is not quite 1, so t has to be less than 4/5. The only number that is up there that is smaller than 4/5 is a 0. So the 0 is a solution of the inequality. The next example says, what are the solutions of 4n plus 2 are less than 7n minus 13? Notice in this case I have 2 variables n on either side of the inequality sign. When my variables are on either side of the inequality sign, I'm going to have to use inverse operations to combine them. I could subtract 4n from both sides, or I could subtract 7n from both sides to get my variable on the variables together. I'm going to choose to subtract 4n from both sides so that I do not end up with a negative exponent, and I will not have to, a negative variable, and I'm not going to have to worry about dividing by a negative in the end. The 4n's cancel out, so I'm left with 2 is less than 7n minus 4n is 3n, and then minus 13. Now I need to solve for n, so I'm going to add 13 to both sides. When you do that, you get 15 is less than 3n. Divide by 3 on both sides, and you get that 5 is less than n. Remember, if you wanted your variable on the left, then you could flip everything around and it's the same as n is greater than 5. This example asks us to solve each inequality. For a, they give us 14 minus 6n is less than or equal to 2 parentheses 7 minus 3n. Notice that in this example, I'm going to have to distribute on the right side of my inequality. So I'm going to have 2 times 7 minus 2 times 3n. I'm going to leave the first side alone, or the left side alone. So I'm going to have 14 minus 6n is less than 14. 2 times 7 is 14, minus 2 times 3n is 6n. Well, if you notice right now, I have the same exact thing on both sides, but I'm going to go ahead and try to get my variable by itself to solve the inequality. I need to add 6 in to both sides. Well, when you add 6 into both sides, the variable cancels out on both because a negative 6n plus 6n is 0. So I'm left with 14 is less than or equal to 14. 14 is less than or equal to 14 because 14 is equal to 14. Because this is true, we can say that all real numbers are solutions to this inequality. So when you're solving and your variables cancel out and you're left with a true inequality, your answer is all real numbers. In example B, we have 4p plus 3 is greater than 9p plus 6 minus 5p. Notice on the right side of this equation I have two variables, so before I can combine on either side of the inequality sign, I'm going to go ahead and combine my 9p and my negative 5p. When I do that, I'm left with 4p plus 3, the left side hasn't changed, is greater than 4p plus 6 when I combined my 9p minus 5p. Now I need to get my variable by itself, so I need to subtract 4p from both sides. Again, when I subtract 4p from both sides, my p's cancel out because 4p minus 4p is 0, and that's the problem on both sides of the inequality sign. So I'm left with just 3 is greater than 6. Well, 3 is not greater than 6. This is not a real true, so there is no solution to this inequality. So in the previous example, when you end and you have a true inequality, you can say that your answer is all real numbers. In this instance, when we were left with an untrue inequality or a false inequality, we say that there is no solution. Today's assignment is on page 202, numbers 2 through 34 even.